Okay, in this video, we are talking about graph of functions. Okay, so in this video, it's not too much calculations involved. It's just more of what do you see in the picture. So in the screen right now, what you see is a graph of a function. And I know this is a function because it passes the vertical line test. So in order for a graph to be a function, you need to be able to take an invisible line and go from left to right on your graph and only touch that vertical line in one place with your graph. So on this graph, if you take your pencil and you go from left to right on this graph, it will only touch in one place all the way across. And I know that's kind of confusing, so let me go to some examples that are functions versus ones that are not. So this first example right here, this is actually a function because if I go from left to right, you see the little dotted red line? That's like that invisible line that I'm talking about. That's the pencil that is moving from left to right on the graph. And as that dotted line goes from left to right, it only touches the graph in one place. And the graph is right here. This is the graph. And this is actually a function. Okay. Look at this second one though. Here is the graph right here. And look at that dotted line. You see how we have a problem with that dotted line because it's hitting the graph in two places at one time? That can't happen. That's why this is not a function. And same thing with the last one on the third option. The graph is actually this little oval looking shape right here. This is the graph. And if I took my pencil and went from left to right on this graph, it would touch in two places everywhere. Look, two places here. If the dotted line was like right here, it would touch in two places here. So that's a huge problem. This is not a function. So when I look at my original problem, this one right here, this is definitely a function because I can go from left to right and only touch in one place. So that is something you can tell just by looking at a graph. So question number one, is this a function? You say yes. Is this a function? You say yes, because it passes the vertical line test. Let's say the question is asking you to find the domain. So the domain is the x values, right? So if I have like a little squiggly line here, I'm looking at the x values. Basically, you're looking at this graph and trying to figure out how wide is this graph across the x. So if I look at this graph and find the very lowest x value, okay, x value, very lowest x value is going to be right here at -8. That's the lowest x value that I have on this graph. And now let me proceed to go across. All of this is part of your graph. All of this, all of this, all of this. Now I'm going to keep going till I get to the highest x value right here. And what is that? 9. So it starts at -8 and it ends at 9. Okay. And there is a solid dot at -8 and right here at 9. I kind of went over it. Yeah, right here it has a solid dot right here at 9. What that means is that we're going to have brackets there. So from -8 to 9. That is our domain. And basically, domain is telling you how wide is your graph. If you were to take a tape measure, if that squiggly line on the screen was a tape measure, this is how wide the graph will be. This is where it starts. This is where it ends. Okay. Now let's look for our question number 3, which is going to be, well, what is the range? If you just look at this picture, can you tell what the range is going to be? Yes, you can. Let's erase this. And range is talking about the y values. So I'm taking the tape measure and I'm measuring how tall this graph is. I'm looking for the very lowest y value and the very highest y value, and making sure there's no gaps. So let me take the red. I'm going to start with the very lowest y value, which is going to be right here at -7. -7 is as low as this graph will go. And then I'm going to start my squiggly line going up, going up, going up, going up, until I get to the very highest point of this graph, and it stops right here at 7. So it starts at -7 and it ends at +7. And let me see if I have solid dots at -7. And yes, I do, right here. And let me see if I have a solid dot at 7. Yes, I do here. So that tells me that my range is, with brackets, -7 to 7. Domain and range. Okay, let's see what else they can ask. They could ask you, erase, erase, erase. They could ask, what is f of -3? They could ask you that question. What is f of -3? And it's like, what? How do you answer that question? If you look at f of -3, -3 is an x value. Because, you know, typically it's written f of x, right? So whatever they put inside the parentheses is going to be an x value. So if they put down find f of -3, they're basically asking you to find -3 on the graph and give me what the corresponding y is equal to. So what I do is I go to my graph and I find -3. -3 is right here. And then the point that's associated with -3 is this point right here. So what is the y value at that point? It is also -3. So the answer to this problem is -3. Let's do another example. Let's find f of 7. Nah, I don't want to do that. Let's find f of 4. F of 4. So this tells me that my x value is 4. So I go to my graph and I find, where is 4? 1, 2, 3, 4 is right here. The graph is associated with 4 right here at this point. What is the y value? The y value is going to be 7. Okay, so they give you an x value, you have to find the y value. Now let's see what else they can ask you. I can keep asking you questions about this. So they could ask you to find this right here. Oh, this is a good one. So it says f of x is equal to -3. So are they giving you an x value or are they giving you a y value? That -3 is a y value. Okay, that -3 is a y value. So you got to go to your graph and let's find all of the -3s. Let's find everywhere where y is equal to -3. So let's find -3 first of all. -3 is right here. Now let's find all the points that are associated with -3. I got one here, I got one here, and I got one here. Anywhere else? Oh, I have one here too. It's a bunch. Okay, so the answer to this problem is all of these x values. So it says, what x values have a y value that's equal to -3? That's going to be x is equal to -8, comma, what else? -3, comma, where else? At 2, comma, and 7. All of these numbers, all of these numbers right here, -8, right here, -3, right here, 2, and right here, 7. All of these will be the answer because they want to know what x value will produce -3, and all of those will do that. Okay, what else can they ask you about this graph? Okay, they can ask you about increasing and decreasing. They can ask you where on this graph is it increasing and where is it decreasing, okay? Increasing and decreasing. Let's start with the first question, increasing. So if something is increasing, it's always going from left to right. So the definition of increasing is basically an open interval, which means it's always going to be parentheses, an open interval that the graph is increasing from left to right. So I'm going to circle the areas that have increasing. And I always tell my students it's kind of like riding a roller coaster. You start on the left-hand side. I'm going to draw a little stick man here. Let's say this stick man is on a roller coaster. So we start going down. This is going down the roller coaster. That's not what I want. But as I hit this point, I start going up the roller coaster. So this is going to be increasing. So don't want this first part, right? Because that's decreasing. I want this part. What interval is this? That interval would be from -6 to, what is that, 0? So -6 to 0 is going to be increasing. But then I start going down the roller coaster again. I don't want that. I want increasing. And so as I hit this point, I start going up the roller coaster. So here I have another area that's increasing. And that's going to be from 2 to 4. Parentheses 2 to 4. Now, definition of increasing is an open interval. That's why I'm putting parentheses on both sides. Then I start going down the roller coaster again. That's the part I don't want, right? And then I have another increasing section right here. And this will be from 7 to 9. So where is this graph increasing? Where am I going up the roller coaster? You're going up the roller coaster from -6 to 0. 2 to 4, and 7 to 9. Okay, now let's talk about decreasing now. When am I going down the roller coaster? When am I going down the roller coaster? So we got to erase all of this stuff that we have on here. Let's erase this increasing. Let's erase this circle because that's increasing also. And we're going to keep the little man there because he's still going to ride the roller coaster, okay? Okay. So now where am I decreasing on this graph? So the little man is going to start out by going down the roller coaster. So this is the area where it's decreasing. That's from -8 to -6. And that is what parentheses because it's an open interval. Then I start going up the roller coaster. Nope, don't want that. Now where am I going down? From here to here. So from here to here, I'm going down. So that's 0 to 2, parentheses. Then I start going up again. I don't want that. But then I start going down here. That's from 4 to 6. Nope, 4 to 7. And that's it. I am going down the roller coaster from -8 to -6, from 0 to 2, and from 4 to 7. Decreasing.